Hello everybody, today we're going to be talking about the herniation of the brain. We will review the relevant normal anatomy, talk about the process of herniation, learn how to detect herniation by noticing disruption of normal anatomy, and review the major types of herniation. The brain is contained within a rigid calvarium, and any lesion producing mass effect will result in herniation of the brain beyond its normal dural confines. To detect herniation, we have to pay attention to the cisternal spaces. First, we have the pericolossal cistern, which is within the interhemispheric fissure, and we see the falx in the midline. Next, we have the suprasellar cistern, which is anterior to the interpeduncular cistern, surrounds the pituitary and infundibulum, and the optic chiasm. Then we have the perimesencephalic cisterns, which are made up of the interpeduncular cistern between the two cerebral peduncles, this triangular-shaped space. We have the crural cistern between the temporal lobe and the cerebral crus. Then we have the quadrigeminal plate cistern. Then the prepontine cistern, which is anterior to the pons. The cerebellar pontine angle cistern, which is lateral to the pons and within the angle between the pons and the cerebellum. To review on the sagittal image, we have the suprasellar cistern above the sella, surrounding the infundibulum of the pituitary, the interpeduncular cistern, the prepontine cistern in front of the pons, quadrigeminal plate cistern. Now let's look at the different types of herniation diagrammatically. Subfalcine herniation below the rigid falx. I have stylized here the anterior cerebral arteries because mass effect from compression of the anterior cerebral arteries up against the falx can result in corresponding anterior cerebral artery territory infarction. Next we have oncoherniation, which is herniation of the uncus over the tentorium, and this time I've stylized the right posterior cerebral artery, which can become impinged against the tentorium and result in a PCA infarction. Next we have herniation of the brain downwards, transtentorial herniation downwards, which would result in effacement of the suprasellar cistern. Mass effect on the basilar artery can result in disruption of the perforating branches from the basilar artery, and this can result in hemorrhage, called a Durette hemorrhage. Next we have transcalvarial herniation of the brain, which is where the brain parenchyma extends outwards through a defect in the calvarium. Now let's begin with our clinical cases. We have leftwards herniation of the brain under the falx. The falx here is bowed, which takes tremendous pressure because the falx is a very rigid structure. The right hemisphere has herniated to the left, and this is not just a matter of midline shift, this is full subfalcine herniation. We can see that the midline has moved to the left with the movement of the ventricular system. Next we have herniation of the left uncus, as evidenced by effacement of the crural cistern on the left. Notice the shift of the pons to the right, with the widening of the prepontine cistern on the left. This can be a very helpful sign. Here we have right ungual herniation, evidenced by effacement of the crural cistern on the right. And we notice on this contrast enhanced exam, we see the enhancing mass with associated vasogenic edema, which is causing mass effect and the subsequent herniation. And we can also see the right posterior cerebral artery and the mass effect on that artery, which could result in infarction. Here we have a case of fairly mild transcalvarial herniation of the brain outwards through this defect. And here we have a case of several types of herniation. First, left ungual herniation. Subfalcine herniation towards the right. We see the etiology is this mixed attenuation subdural hemorrhage. And we also have downwards transitorial herniation of the brain, effacing the normal suprasellar cistern. This is a different patient with transitorial herniation of the brain downward, and we see a hemorrhage within the pons compatible with a direct hemorrhage. And here's another patient that's difficult to see the suprasellar cistern, and we also don't see the quadrigeminal plate cistern. Now this actually turns out to be upwards herniation of the cerebellum. You can start to see some other findings such as layering blood within the ventricular system. And here's another patient with the same entity of upwards herniation of the cerebellum, effacing the quadrigeminal plate cistern, and downwards herniation of the cerebellar tonsils through the foramen magnum. And here is a sagittal representation of that same patient where we have upwards herniation of the cerebellum, downwards herniation of the cerebellar tonsils through the foramen magnum. We see the cause, this large cerebellar hemorrhage. We also see that the pons is actually displaced upwards towards and into the suprasellar cistern. Remember, whenever you see cerebellar tonsillar herniation, you have to ask yourself if the tonsils are being pushed down from above, or if there's intracranial hypotension before jumping to the conclusion of a Chiari malformation. So we talked about the anatomy of the cisterns, we talked about herniation types, and we mentioned some potential complications of herniation. Thank you so much for your time.